Hello class, how are you doing? Listen, I hope you guys got the word about tomorrow, Friday, and Monday. Those are going to be days which are not vacation days, but days which you can use to kind of catch up and to kind of catch up on work maybe that's gotten piled up in the last couple of weeks or so. So this is going to be, we're going to have a lesson today, but this is not going to be, okay, so what's today? Thursday. So our next day would have been Monday, but it's not, okay, because that's not going to be a new lesson or a new class day. So what we're doing today will be due next Wednesday. Okay, are we clear on that? Okay, next Wednesday, and that'll be on the calendar. The homework for this day will be on the calendar. Okay, all right. Now we're coming up actually pretty close to the end of this unit on definite integrals and on the definition of integration, and we're going to have after this probably one or two more lessons after this. And then we are going to have a test, okay? And then that will be, so more about that coming up, alrighty? Very good. If you're asking Mr. Waters, will that be the very last test before the end of the school year? And the answer to that is, I'm not sure. Okay? All right, very good. So we're at least going to have a test on this unit here, the chapter 5, on the definition of integration. Okay? Okay, so let's see here. Now, before we did that, though, before we start with the lesson today, I want to talk a little bit about a couple of our homework problems. Number one, okay, so a couple of our past homework problems. One of the homework problems is on page 247, and it was number 18. And now I'm going to go ahead and I'm going to zoom in on this. Okay, so we get closer in. There it is. One more time. There we go. Okay. And it says, show the velocity in centimeters per second of a particle moving along the x-axis. Okay. Or that's what these graphs show. They show the speed, the velocity, actually. Compute the particle's change in position left or right between the times t0 and t5. Okay, now keep in mind that this is supposed to be net change, right? In other words, like the guy we had in the lesson who's walking away and then back, walks away from his house and then back from his house, okay, we want to calculate the net change in position from his house, okay? Not, as it happens, the total distance, but the net distance from his house. So here, we look here and we see that here the graph is at 2. Now what does that mean? Well, if this is the velocity graph, that means he's walking, or the particle is moving, at 2 centimeters per second. And according to the 3 there, it's moving for 3 seconds, right? And so that's, the area under that rectangle is 2 centimeters per second. Times 3 seconds is equal to, it goes, that total distance, and you cannot see that. Okay, there it is, sorry. Guess I zoomed out a little bit too much. Hang on, let me zoom back out again. Okay, there it is. Focus again. Okay, so, sorry, I don't really want to start this video over again, so I'm just going to keep adjusting here till I get it. Perfect. Okay, good. So it's gone 6 centimeters, right? Now, down here, what does this mean? This means -3. What does that mean? That's supposed to be a speed. Well, keep in mind that because velocity is a vector, that means the particle, although we can't see it on the graph, what's happening with the particle is that it moves this way for 3 seconds, and then as you can see, it's the negative speed travels from 3 to 5, so that means it's traveling back this way, right? at a speed of -3. So we get 2, so its speed is -3 centimeters per second, times, and you see here that the time interval is 2 seconds. So very conveniently, -3 times 2 is -6. And what that means is, not that there's some kind of weird Star Trek, timey-wimey kind of negative distance. It just means that that's distance reversed. It's distance back towards the particle's original position, right? And the idea of this is that if the travel outwards completely balances the travel out backwards, the net distance that particle has traveled from its beginning spot is equal to 0. So that's actually the answer that we wanted, was that the particle had gone, 0 distance. Does that make sense? Okay, so we didn't want to say 6 out and 6 back. We wanted the net distance, its net position, with respect to its beginning spot is equal to 0. Okay, very good. Okay, so that's that. Now the second one was more mechanical, and that was on the homework on page 253. It had to do with number 9 here, was one of the ones I checked. And it says, use a calculator or a computer to find the value of the definite integral to 4 decimal places. Now I'm pretty sure that there are online, like, integral calculators, right? For example, there's a website called Wolfram Alpha that will do it for you. But our calculators here, with the possible exception of some of our oldest TI-83s, well, actually even the TI-83s will do it. It's just that the old TI-83s don't have the convenient little visual menu that will tell you what to plug in where. But anyway, what we're supposed to do here is we're supposed to calculate the actual distance, the exact the exact area of the 2 to the x curve from 0 to 3. Now what we're calculating here, I'm going to draw a handy-dandy little picture of it just in case we're not clear, is that here's a graph, right? And let's say this is 2 to the x is going like that, right? So here is 0 and here is 3, let's pretend. While we're looking for what we're about to calculate is that exact area, okay? And whatever that, in the context of that function, whatever that area might represent, okay? Could be a speed, could be a total population based on population growth curve, could be different things, okay? Could be a total number of people infected by a disease based on the curve that is the growth, that represents the growth rate or the infection rate of the disease, okay? Anyway, so how do we do that on the calculator? Now, we're going to learn, or you would learn, methods for doing this by hand. Actually calculating this by hand would involve taking the antiderivative, right, of whatever, of 2 to the x, whatever that is, right? That means that's a function that if we took the derivative of it, we would get 2x, would be the function that gives us the area under the curve. Now, if not for the Corona break, we might have been able to learn something about how to do these things by hand. And we might still be able to do a little bit. But for the most part, I'm going to focus for us, I'm going to focus on getting us through chapter 5, right? And make sure we really know how to do that. And we understand what some of the applications and uses of integrals are. But actually taking these integrals is just a matter of formulas and procedures that you would learn, kind of like what we did with chapter 3, where we learned all those derivative formulas, okay? Anyway, so how do we do that on the calculator? So now, one of the reasons, now some people were struggling with this on how to do this on the homework, right? On this homework, and one of the reasons why I want to make sure we know how to do this is you're going to need this for today's homework, okay? So remember, we're trying to find the area under the curve from 0 to 3 of that function 2 to the x. Now, our calculator will do it for us. I'm going to go ahead and actually zoom out a bit so we can see more of it. I'm going to use the math key here. Boom. And I'm going to choose, I want choice 9 that says Fn integral. That's the integral of a function. Choice 9. And notice that if you're lucky and you don't have one of the really old TI-83s with the old operating system, you get this handy-dandy little picture, right? Now we just plunk in the stuff that we want. We want from 0, and then I arrow up, and I type in 3 there. Then I arrow to the right to get into the little function box there. Now I just have to enter 2 to the x. So I'm going to type in 2 for the base, right? And then exponent. See where my finger is? Here's my finger. Okay, right here. Exponent to give us 2 to the x. Then I use the x key to put the x in there. And then arrow to the right again to get to the next blank box. And I just type in x. So we want, in other words, we just type in what it has on your page there. From 0 to 3, 2 to the x dx, the integral from. Okay? Hit enter. Boom. Now that's 10.00988. Now in your book it said write that out to 4 decimal places. So that would be 10.0989 because we'd round up from the 6. Okay? So that's how that works. Alrighty? And so on our homework, when it says, and you'll see this in our lesson videos coming up, you'll see, oh, you need to calculate this exact integral. You're going to use the calculator procedure to do that. Alright? Very good. Okay, that's enough, I think, for this video. Stay tuned for the new thing for today.